Okay, so let's try an example. Let's see if we can find the flux of the vector field zyx across the unit sphere. So, first things first. They said the word flux. Okay, when they say the word flux, you need to think the integral over S of f dotted with d area. Okay?
Okay.
And then the first thing you need is what? Okay, so I would accept two things here. You either need to remember that this is going to be the double integral, right, of f of r of something dotted with,
Those somethings.
what's the thing that goes here?
The two thets cross.
Yeah, the two partials crossed, right? So I'm going to have to figure out what those are. And then I'll integrate d, well, d whatever they are. You guys cool with this? To even start that frickin' thing, I need a, I need some kind of parameterization, right? So trot yourself out of parameterization. So we're thinking sphere, right?
So I'm thinking r of theta and phi.
Yeah, but I'm too dumb to jump to that, so I'm still going to do this thing, right?
Okay.
I'm going to take a sphere, I'm going to draw a little fellow on it, and I'm going to think, okay, there's two directions. Those feel like theta and phi to me.
Yep.
So I'm going to write down the spherical thing, right? So r of theta and phi, and you guys are telling me that's
Sine phi cosine theta.
sine phi cos theta, comma, sine phi sine theta, comma, cosine phi. And where'd your rows go?
It's a unit sphere, so rho just ends up equaling 1.
Perfect. Good, right? Unit sphere, row is 1. So this would be spherical conversion factors, right? If there was a row tacked onto each one. But row is 1, so I just dumped it. Cool? Is this the only way to skin this particular cat?
No, but it's the way that we do best.
No, it's not the only way, but it's the right way. You guys cool with that? Like, you can make lots of parameterizations of a sphere.
Don't make your life hard.
They're all going to be worse than this one. Okay, so I need to, like, thinking back up here, right? I'm thinking, okay, f of r, what does r depend on?
Theta and phi.
Theta and phi, right? And then, so, I need a, do you guys see that I missed something here? What did I miss for this flux integral?
Orientation.
Yeah, I missed an orientation. So I'm just going to slap that in here as assuming oriented out, I guess. They didn't tell me, so I'm going to make some assumption, and then I'm going to bitch about them later to the other people I work with, right? Be like, Steve gave me he told me to calculate this thing, but he didn't tell me which way he wanted it to go, so he's an idiot.
It needs to be on the outside of the sphere.
Yeah, so now the thing I need that orientation for, right, is to figure out which R you cross with which R. You guys see that? So what I need to think about is when I'm on this little surface, and this is why I actually do this stupid thing over here. Like, here I am, right? Which way does increasing theta go?
Theta gets increased clockwise.
So what I mean is if you start with theta's 0 and you go to theta's 0.001, which direction are you going around the sphere? Yeah, good. It depends on how you pick the parameterization, right? But I picked the usual spherical parameterization. So r theta is going to take me that way. right? Like looking at this thing from down the positive z-axis, it's going to take me counterclockwise, right? Which way does the phi take you?
Down, kind of? Like...
Yeah, it increases your declination, right? So it's going to go this way. So that's going to be r phi. So which order do I want to cross these in to have me pointed out?
You have to do phi, then theta, don't you?
Phi crossed with theta. You guys see that? If you do it the other way, what are you going to get?
Inward.
Yeah, you'll just get this thing with a minus sign on it. You guys cool with that? Like if all you care about is the flux across this thing, well, you just take the absolute value of the answer anyway, right? But if you care about the flux across this oriented outward or oriented inward, then you need to like think about this for a second.
If you were to do it with theta crossed with phi instead, would you get negative values?
Yep, you'll get exactly the same answer, but with a negative sign slapped on it.
So you just know if you do it wrong.
Yeah, so you can kind of look at your vector field sometimes and be like, okay, the answer on this one's going to be positive. Like it's tending to go out through the sphere, right? If it's tending to go out through the sphere, well, then I'm going to get a positive answer if my sphere is oriented outward. So if I go through all this and I get a negative answer, I'm just like, oh, shit, I probably did the partials in the wrong order. Whatever, I'll flip the sign.
Is this why we've always done like sine of phi, then cosine of theta, and not the other way around? Just that just happens to be the right-hand rule, so that's why we organized it that way?
No, I don't know why you guys started organizing it that way. It wasn't me.
Oh.
I would write those the other way, because theta comes before phi in the Greek alphabet.
Oh, so that
You
was...
guys switched that on your own. I didn't do that.
Oh, okay, so that's just coincidence.
Is that in the book?
Yeah.
Okay, sure, whatever. It doesn't matter at all. I don't know why they did that. Okay, so what I need to calculate now is what is my next thing here?
You need to figure out what r phi and r theta is and all that.
Yep, so you need your partial derivatives. So go get them. Like a big part of doing this is just actually having the wherewithal to be like, okay, I'm gonna go calculate those now. It's gonna take a second. It's not so bad once you get started, but if you sit there and dread it, it's gonna be bad. So, oh wait, say that again, Chris.
There should be 2 product rules.
No,
Well, one for each of the components.
no, don't be crazy. Don't do product rules, because they're different variables. Even though they're both round.
Yeah, I like.
Okay, so when you do r theta, what do you get for this first coordinate?
Theta. Negative sine phi sine theta.
Negative sine phi sine theta, comma.
Cosine
The sighing.
sine phi cosine theta.
Sine phi cosine theta, comma.
Negative sine.
No, zero.
Yeah, it's just 0.
Oh, yeah, zero.
Score! I love it when there's 0. Why do I love it when there's 0?
Because you don't really have to touch it.
Because that's going to make your cross product a shitload easier, which is the next thing I have to do with this horrible monster,
Oh,
right?
cross.
But it's okay. You just one step at a time, it'll be all right, for real. So, our phi is what?
Cosine phi cosine theta, cosine phi sine theta, and then negative sine phi when we do it.
What?
That's the cosine phi sine theta is the last. Is this y?
Cosine phi
Sine.
sine theta.
Sine
Thank
theta.
you.
And then a negative sine phi as the
And a negative sine. Okay. Now, if you did this right, you wrote all this stuff, one right over the top of the other one. The reason you want to do that is you can save yourself a bunch of time. Right? Because what you need to do is cross product these two things.
But we should have done phi on top.
Shit. I'll just flip the sign at the end.
There you go. Okay.
You guys cool with that?
Yes.
Okay, so I'm going to slap a minus sign here and do this one. Good? Okay, and then I'm just going, all right, there's an I, there's a J, there's a K, right? And then I'm taking the determinant of all of this jazz. And so I'm getting that R theta cross R phi is so I need the J column and the K column, right? So I'm doing this stuff minus that stuff. The minus that stuff, thankfully, doesn't matter. So I got negative sine squared phi cosine theta. Okay, and then the J one, oh hey, there's another 0 in that one. And I need to be subtracting that, right? So I need to remember to flip the sign on this other bit. So I get plus sine squared sine phi, but there's another minus sign in there, so I got a minus sine squared theta sine phi.
Wait, what?
Sine squared phi sine theta. Is all good with that?
Why negative still?
So when you're doing a cross product, right, the J really should have a minus sign on it,
Oh yeah, that's right, damn.
right? Because you're doing a determinant. So you're doing plus this, minus that, plus that. Okay, and then your last one, when you cover up the K column, so your K component, is a total mess, right?
Yeah.
So that one's minus
Sine.
Sine.
Cosine.
phi
Cosine phi.
cosine phi
Sine theta.
sine squared theta, right?
Minus.
And then minus the other way. So minus the other way is a sine phi cosine phi
Cosine squared.
cosine squared theta.
Fantastic.
That's a lovely.
Oh, but that's very convenient, right?
You can factor out.
You can factor out a minus sine phi cos phi, right? And then there's a Pythagorean identity left.
Oh.
Jiggle for one.
So none of that shit matters. Guys all good with that?
Yes.
Look for this. Anytime you're working with spheres, you need to keep your eyes super open for the Pythagorean identity. Because it's gonna be in there somewhere.
Was it the sine squared minus cosine squared?
So really it's that this is minus sine phi cos phi times sine squared plus cosine squared. And those are both theta. And then this is 1. Is all good with us?
I noticed there's a negative sign on each and every one of them. So
Oh good, there's a negative sign on everything and I'm going to make the whole thing negative anyway. So I'm just going to flip all those. You guys cool with that?
Yeah.
Okay, so oops, I don't want to erase that. Okay, cool, let's just do it right now. So this guy is going to be the double integral. I'll need bounds in a second, right?
Really, you need balance?
And then here I need something, and then I need to dot with this thing, and I'm going to flip the signs. So I got a sine squared phi cos theta, comma, sine squared phi sine theta, comma, sine phi cos phi. And then there's, at the end here, there's a d, there's got a d theta and a d phi, and I'm not totally sure they want to be in that order. So what order do they want to be in?
I think it actually doesn't matter in this case because we know that theta is going to be 0 to 2 pi and phi is going to be 0 to pi.
So I'm doing the whole, I'm going the whole sphere, right? And the sphere is a rectangle in the sense of thetas and phis, right? So it doesn't matter which order you go in. The thetas are going to go from 0 to 2 pi, and the phis are going to go from 0 to what? Pi. Okay. And then what should go in that first slot there?
F of R for rho and phi, or
Okay.
theta and phi. So
Good thing it's just Z.
yeah, it ends up being
Okay, so it's zyx. So it should be cosine phi,
then sine phi, sine theta, so that stays the same.
sine phi, sine theta,
And then sine phi, cosine theta.
and sine phi cosine theta. Okay, and then you need to do this dot product, right?
That'll be fun.
Okay, hopefully something's easy. Equals integral from 0 to pi, integral from 0 to 2 pi of, what's your first one? Sine squared phi cos phi cosine theta. Okay. You know it's Calc 3 when you can use up a whole marker in a file. Okay, what's your next component? These things, right? So you have plus sine cubed of phi sine squared theta. Okay, and then your last thing is
Sine squared phi and cosine squared theta. Oh, wait, yeah, sorry.
Same thing as the first one.
Yeah, theta, yeah, cosine theta, cosine phi.
oh, I should switch those for aesthetics. Okay, and then you've got at the end here a d theta d phi, right? Okay.
That went too crazy.
Now,
There's probably some sugar in it. Yeah, it makes it look nice.
probably we can make this easier, right?
Make the first
Let me
one and the
split
second
these
one
up.
just.
Oh, so we have a sine squared of phi on each one, so we can pull that out.
Like, you have a whole thing together.
Yeah, so this thing and that thing are the same, right?
Yeah.
Okay, so I can do this. I can slap a 2 on this one and dump this last thing. Okay, cool.
We're doing it. Where's the 2 cosine theta?
Let's see, is there anything I can get out of this that's any easier?
You could get sine squared of phi, but I'm not sure that helps.
Yeah, I could factor out a sine squared of phi, but what I'm going to be left with still has lots of stuff in it, right? You guys see that? So, and both variables, so probably that's not going to be super duper helpful.
If we split into 2, wouldn't the first one be 0? Because we have a cosine theta over 2 pi. 0 to 2 pi.
Cool. That's a good observation. You guys see that? So if I split this into 2 pieces, I got, okay, this is 2, and then I got the integral from 0 to pi, and the integral from 0 to 2 pi of sine squared phi cos theta d theta d phi, right? So that's my first thing, and then I have plus the integral from 0 to pi, integral from 0 to 2 pi of sine cubed of phi sine squared theta d theta d phi.
Can the camera see that?
Probably. Okay. And then we can pull that double integral trick, right?
Yep.
You guys seeing that? Okay, so I'm going to pull my double integral trick on this first business here. I'm going to say, okay, so I got 2, the integral from 0 to pi of, what are your theta, or your phi things there? So that's sine squared phi cos phi. d phi, and then there's times an integral from 0 to 2 pi of
Cosine
cosine theta d theta. Oh, but this part's going to be 0.
Yeah.
And you're multiplying.
Yeah.
Okay, so all this crap's 0. Good. And then you've got plus,
You can do the same thing with that.
and on that one I can pull everything apart a little bit. So I got the integral from 0 to pi of sine cubed phi d phi times the integral from 0 to 2 pi of sine squared phi d, or sine squared theta d theta, right? You guys all with me on this? Okay, so how do you integrate these? Wait, is anything 0, obviously? That would be a good thing to think of, right? Like, maybe something 0.
It's sine squared 2 pi.
So this guy, is that guy 0?
No.
No, because it's always positive, right? Shit. How about this guy?
I don't think it's obvious if it is.
So it's between 0 and pi, right? And it's sine.
Sometimes it's negative, sometimes it's positive.
No. Oh.
But the area.
Sine's always positive between 0 and pi.
Yeah. Oh, that's quick.
You guys see that? Like if it was cosine, I might have a leg to stand on there, but it's not. Crap. Okay, so I have to deal with both of these. But I got rid of a bunch of shit. Maybe,
Yeah.
like, it'll be okay. I got this. Right? One step at a time. So, do you guys remember how to integrate sine cubed?
It's in the back of our
Look on the
book.
back cover. of the-
What? No, don't be lame.
It was nice in Calc 2 when we had the sheet in front of us every test, every time we did it, it was just like.
Merrill is so easy on you guys. Okay, so the way you integrate sine cubed is you think to yourself, I don't know shit about sine cubed, but I know about sines and cosines. So I'm going to think about this guy as sine times sine squared.
And then the sine squared becomes 1 minus cosine of 2.
So that would be sine of phi minus sine of phi cosine squared of phi d phi. You guys with me on that? Cool.
Is there
And then I need to-
divide by 2?
No,
Oh.
that's just the Pythagorean identity. Do you guys want to see that written out more carefully?
Nah.
Yeah. Okay, so slightly uncarefully, but with great feeling. That's sine times sine squared, right?
Okay.
So I'm thinking sine squared plus cosine squared is 1.
Oh, okay. That's
So
right.
sine squared is 1 minus
Okay.
cosine squared.
Okay, thank
So
you.
this is
That's all I was checking.
sine times 1 minus cosine squared. So I
Okay.
get that.
Okay.
Cool, cool?
Yeah.
And then times, what do you use for sine squared?
You can use that.
Is that where we
Yeah, use the half angle identity. So you got the integral from 0 to 2 pi of 1 minus cosine 2 theta over 2 d theta. Okay, something there is easy.
is the
Cross out the whole cosine part, because that's a function over 2 periods.
Yeah, cosine's a function, cosine of 2 theta there is going to be a function over 2 periods, so dump it.
You're left with 1/2.
So you're left with a 1/2 that you're integrating from 0 to 2 pi.
so it's just
So that piece is going to be a
pi.
pi. And then on this other guy, I need to think a little bit. So let me do that. This whole dude here is pi. Okay, so I currently have, I need the integral from 0 to pi of sine phi d phi right? Minus the integral from 0 to pi of sine phi cosine squared phi d phi. And then I need to take all this crap and multiply by pi. Cool, cool?
Where, you wrote 1 minus cosine 2 theta? Is that what that says, or is it 1 minus cosine squared theta?
This guy?
Can't really, yeah.
This guy's a 2 theta. That's from the half angle identity.
Oh, okay.
This guy's a cosine squared. That's from the Pythagorean identity. Sorry, there's lots of trig in this one.
So those both sine squared theta goes to both of those things.
The-
Like the 1 minus cosine squared theta and also 1 minus cosine of 2 theta over 2. Right?
Oh yeah, and then all of this crap's being multiplied together.
Should there be brackets on the top times the integral from 1/2 of the d theta? From your last step?
Oh, this thing? Yeah, I put a pi on each thing.
Oh, so that's the same thing.
I distributed the pi.
Do we use
You
the
don't have to.
with the cosine
You
squared?
could certainly do this.
Yeah. Would do the half angle identity for cosine squared help us? Or?
No, don't do that.
And then just make it a little bit worse.
Okay, so the integral from 0 to pi of sine phi should be easy. What is that?
2.
2.
Thank God.
Pretty good with that?
He was doing this.
Okay. And then I have minus, ruh-roh. How do you do that one?
Have a U
You could do it.
times du situation.
Yeah, so that's a u and a du situation, and your u is
Cosine squared.
cosine squared. No, don't do cosine squared.
Yeah.
Because if you do cosine squared, you'll get a 2 cosine sine, right?
Yeah.
Oh.
Plus or minus something. So you want u as cosine phi, so du then is
Sine.
negative sine phi d phi. Right, so I have now, after my u substitution, I have the integral from somewhere to something, right? Of what?
Of phi equals 0 to phi equals pi.
Wait, hang on. I'm confuzzled.
Sorry.
Oh, you're doing phis. Okay, sure. So we can have from phi is 0 to phi is pi. Okay. Where's your du for this then? I got a sine phi and a d theta.
U squared.
Oh, and I'm going to lasso that negative, so that's going to make this a plus. Right?
Yep.
And what's left?
U squared du.
There's a u squared du. Okay, and let me dump these thetas. So when theta is 0, what's u?
0.
1.
Wait.
Cosine of 0, which is 1, right? And when theta is pi, cosine of pi is
-1.
okay, cool. Okay, so I got pi times 2 plus second?
Negative third minus the third?
So that's u cubed over 3, right?
From -1 to
Evaluated from 1 to -1,
Just,
which is backwards, right? But that's okay. You just have to do the top minus the bottom. So you got pi, wait, I'm going to write my punchline over here. Victoriously, I have pi times 2
Minus
2/3.
minus a third minus another third. Crap, I said it was victorious. How many thirds is 2?
6.
So 6/3 minus 2/3 is pi times
So it's 4 pi over 3.
4/3.
I think we get the idea.
It's actually mostly for the video because you can't sort it out. So I got a number,
Which is 4 pi over 3,
which is 4 pi over 3, which means something.
Since, yeah, 4 pi.
flux.
over
Yeah, that's
3.
the flux through your sphere. You guys cool with that? So what are the units on flux through a something?
Area of the thing.
Depending on what it's flowing.
Units per, units.
Yeah, so it's-
area per time.
It's volume, usually volume units per time.
Yeah.
So the final.
Yeah, units
cubed
of.
over time.
Yeah, so like flow of water, right? Like if I'm measuring the flux through a net, that's going to be measured in cubic feet per second. Or if you're measuring the amount of flow that comes into your reservoir, you would measure that, of course, in acre feet per hour. Because duh, what else would you use?
Also, thank you for giving us somewhere around like 40 of these.
Yeah.
So it should be noted, right, that this is as bad as they get,
Thank God.
right? Because this is all in spherical, so it's all trig, right? When they're planes and stuff, things are easier. You guys cool with this?
Okay.
When you do a surface, so, hang on, let me shut this.